Okay, plan tonight is to look at something called parabolas. Now, parabolas is also working with graphs. All right, so we're working with the x and y axes. Your x and your y. Okay, but instead of a straight line, instead of the sine graph, instead of the cos graph, we're working with a graph that looks like that. All right, we're working with graphs that look like that. Or for the case of my argument here, no. Now, why do we need graphs that look like that? All right, when will you ever use them? Used quite often. You're trying to map out maximums. Okay, trying to understand maximums. Okay, because there's always a maximum there. Okay, so you've got a maximum on the y and a corresponding x value. Okay, now an example where this could be used is quantity of medication. Okay, so if the x-axis along that bottom axis was an ever increasing amount of medication, okay, then there's a perfect amount to give someone for it to be most effective. So if you had the y-axis 1, 2, 3, 4, blah blah blah, all the way up to 100% effective, okay, and you had the x-axis showing you the amount of medication. There's a point at which we'll give the perfect amount of medication to get 100% out of it. If we give a little bit too much medication, all right, if we go past that, if we go to the right of that, right, if we give a little bit too much medication, then it will stop being as effective. It will start actually being detrimental to the person's health. If we give a little bit too less than that, okay, to the left on the x-axis, again, it won't be as effective. So you can map out, you can graph out things like effectiveness of medication, or if you want to look at it another way, this is also how Amazon price things. When you buy something on Amazon or Ryanair, okay, this is how Ryanair price their flights. Bizarrely. Okay, if you have sales of flights, okay, so number of sales, and you have cost down in the x-axis. As you increase the cost, there's a perfect cost for these flights that maximizes the amount you're going to sell. If you go past that cost, it's going to start going down. You're going to sell less because people can't afford it. Okay, if you go much cheaper, okay, people will actually start to devalue the hotel, the holiday. It's bizarre. You get that in Amazon sales as well. There's a perfect value that allows people to see that it's worthwhile spending that money. So if you go past that value, the sales actually start to drop. If you're below that value, people don't perceive it as a good quality product and won't buy it. All right, so parabolas are quite important in that respect. They work out a maximum. Now, we've worked a lot with some of the skills that we need for determining things like parabolas. Parabolas are just using quadratics. So when we were doing things like that, and we were working out the factorizing, okay, to find the values of x. When we were doing factorization earlier, okay, a common factor, difference of two squares, and our trinomials That's CDT process. What we were trying to figure out there was where the parabola cuts the x-axis. So we were actually using that. We were actually building up the skills that allow us to look at a graph like this. Graph in that shape. And what that factorization process did was work out where it crosses the x-axis. All right. The factors are where it crosses the x-axis. So we already have one of the skills that we need tonight. We also looked at something called completing the square. Now what that does is allows us to find turning point. Okay, so completing the square was when it was in the form of x plus a plus b. Okay, when we changed a trinomial into a new form for x. Sorry, I did not use the wrong one. It's because it's for a reason. I'll do my Q's the wrong way around because it's a Greek letter Q. Okay, so we've already done things. We've done completing the square. We've done factorization. So we're building up actually parts that we need to do tonight to figure out. So if we were to sketch a parabola, if you got asked to sketch a parabola or find a turning point of a parabola, then you know how to do it already. If you were to find the factors of the parabola, you know how to do that already. So there's not much to build on, we're just building on those skills and just seeing how that goes into our processing. Okay. Parabolas can give you a maximum, they can also give you a minimum. Okay, so minimum turning points. Okay. Another key part of, that's just a turning point now. Minimum turning point. Find that the same way. Okay, another key point of a parabola that we find is where it cuts the y-axis. Now again, we already have the skills to do that. It cuts the y-axis when x equals 0. So we just substitute x equals 0 into our equations and we get the answer. Again, that's a skill that we have. We can substitute numbers into equations and we can work out the answer. So again, it's something that we don't need to learn. All right. So we're on a good point. Let's start with defining roots. A wee reminder for ourselves. Okay, just factorization. The following graph has the equation x squared minus 4 x minus 5 equals 0. Okay. The following graph has the equation x squared minus 4x minus 5 equals 0. Find the factors. What we'd do is we'd go through our CDT process. All right. So x squared minus 4x minus 5 equals 0. Carry out our CDT in that trinomial. Is there a common factor to simplify that? Can we do the difference of two squares? No, it's a trinomial. Okay, now remember, this is where we do our add and multiply. We're adding a number together to make that b term, two numbers together to make the b term. We're multiplying two numbers together to make that c term. Okay, remember the sign. So one of the terms has to be a positive, one has to be a negative. So I do that just as a wee reminder. Now, my multiplication pairs for -5 will be 1 and 5. Okay, that's it. If I was to get a negative, one of them has to be negative. Remember, I'm adding them together to get -4. So +1, -5. Now that gives me x plus 1 and x -5 equals 0. Okay, so that's where we took factorization to. Now the final line is working out the value of x's. Okay, now all we do there, the final step for us, is we take both of these brackets and we take them to one side. So we take one over here, we take one over here. I always say x plus 1 is equal to 0. So x is equal to -1. X minus 5 is equal to 0. X is equal to +5. So I'm changing whatever I've got there, and I'm making it equal to x. So that +1 goes to the right-hand side and becomes -1. That -5 goes to the right-hand side and becomes +5. So my roots, okay, my roots of this graph are where it crosses -1 and where it crosses +5. That's where it crosses the x-axis. Okay, that's why we were doing that factorization. So our CDT process. But skip ahead too quickly, let me know. Okay. Find the roots of 2x squared minus 6x equals 0. Okay, find the roots, it's factorization, it's our CDT. Okay, so always start with a common factor. Is there a common factor here? Yes. Okay, so remember, common factor is something that goes into each of the terms. Is there something that I can put into that term and that term, or remove from that term, that's common? So I can remove the term 2x, and I can put in the bracket x minus 3. Okay, so I've simplified that down to get 2x and to get x minus 3. Now, if I was to open that bracket up again, I would get the line above. Okay, so 2x multiplied by x would give me 2x squared. 2x multiplied by negative 3 would give me negative 6x. Okay, now to work out the roots of that equation, I then take 2x to one side and the bracket to one side. 2x equal to 0, x minus 3 is equal to 0. X, 0 divided by 2 would just be 0. Moving the 3 over to the other side would give us positive 3. Let's have a wee quick look on Desmos. Is that still sharing my screen? What was that? Yeah. X 2x squared. 2x squared minus 6x. All right, if I zoom out there, you can see it's a parabola. Okay, you can see it's a parabola. And you can see it's crossing at 0, 0. So when x is equal to 0, and when x is equal to 3. So it's cutting the x-axis at that point. So the roots, when we're finding out the roots through factorization, that's what we're trying to achieve. We're trying to understand where that point is. All right. Now, that was using common factor. Find the roots of graph y squared minus 49 equals y. Find the roots means factorize. So without CDT, is there a common factor? No. Is there a difference of two squares? Yes. Now remember, the difference of two squares is that term a square term, and is the second term a square term, and is in the middle a minus. Okay, difference is something take away something. Okay, so it's two square terms should be taken away. So it's just y minus 7, y plus 7. Okay, final answer. The roots of that, now just using y, don't get thrown by that instead of x. Y minus 7 equals 0. Y equals 7, I'm just changing the letter. Y plus 7 equals 0. Okay, so it cuts my axis when those terms are there. Okay, these are skills we already have. Just to finalize that, so find all right, we need to go through our CDT process. No, none of that, none of that. Trinomial, adding together, get positive 9. Multiply together to get, remember we multiply C by whatever numbers in front there, so it's 2 multiplied by -5. So it's plus minus minus plus. Okay, that just reminds me that one of them has to be positive and one negative. 1 in 10 2 and 5, that's all. And then it's going to be positive 9, so it's going to be negative 1. Okay. None of this is ringing true with you. Go back and look at when we did this in factorisation. Okay, so we take that 2x minus 1. Okay. We take the 2x minus 1 over, put it in a bracket. We have 2x plus 10 in the bracket, and then we're dividing that by the number in front of the x squared term. Now I need to simplify these brackets as much as I can. Okay, so there's a common factor that I can take out of the bracket. So the first bracket, no. Is there a common factor I can take out of the second bracket? Yes. The first term's 2x, the second term is 10. So I can take the number 2 out of there. So I can get 2x minus 1 times 2 times 2x plus 2. X plus 5. Okay, all over 2. Those 2's cancel each other out. Boop, boop. I'm left with the brackets. That, and that means 2x minus 1 equals 0, and x plus 5 equals 0. X equals negative 5, nice and easy. And x, let's say 5's. X, take the negative 1 over, comes positive 1, take the 2 over, it comes divided by 2. So x would equal a half and x would equal negative 5. So that factorisation we did, okay, was finding the roots of these graphs. If I put that into, I put that graph into Disney, you'll get both. They usually do a factorisation just on its own, and then they'll do one to do a curve, and then they'll do one as a question. All right, you can see the parabola, normal shape that we're used to. That we see, okay, what we were finding out, where it crosses the x-axis. Crosses the x-axis at 5, and it crosses the x-axis at a half. Okay, so that's factorisation. Completing the square. Again, this is just taking our trinomial, quadratic, whatever you want to call it. Okay, so it's just any equation that we've got in the form of ax squared plus bx plus c. That's just a trinomial quadratic, okay? Now completing the square is a process where we're taking that and we're putting it in a new form. The trinomial and quadratic, for what we are doing, are interchangeable, okay? So I'll keep saying trinomial, I'll keep saying quadratic. For what we are doing, for what we are looking at, they're interchangeable, okay? So putting a trinomial quadratic into the form of x plus p plus Okay, again, look back at your notes of when we did this. Okay, the value in that second point is just our b value up there divided by 2. Q is slightly more difficult. It's minus b over 2 squared plus our c value. All right, again, look back at the notes just to make sure that makes sense to you. Okay, maybe take an example I've already done. X squared minus 4x minus 5. Oh, completing the square. X squared. So we have x plus 4/2. And then you get minus squared, squared, and then plus minus 5. All right, there's a lot of negatives going on here, but I'll tidy that up. So that would be -2. Take away, so that would be negative squared before. Okay. So that's completing the square of that trinomial. That tells me the turning point, believe it or not. Okay, so if I go back,
Wait, I'm confused. That's not the way that I would remember it. Or have you just wrote it out a different way?
what do you remember it as?
I don't know, like just the way that you wrote that down there, it just looked a bit different. Like, cause that, like, you didn't do like the b over 2 thing and kind of laid it out that way. Or did you in some sort of mathematical way that I've not been able to see?
No, that's cool, that's cool. Yep, so 2 -9, let me just check that's correct. 2 -9, cool. Yeah, so the b over 2 is that part. So -4 is b.
Yep.
2.
Right, okay.
Negative b over 2 squared. So your b over 2 is here.
Mm-hmm.
And then plus your c value. So you're, I maybe missed a line. It would have made more sense, but
Yeah. Okie dokie.
is that okay? So as the way we did it.
I think as well, like the last time, like adding on, I don't know, I just feel like that looks totally different. But it makes sense, like I know how you got the answer, it just, I don't know why.
I just looked at people's faces in the class and to see if they felt it looked different, but they looked like they'd never seen it before at all. So, yeah, double check for me if you look back in your notes. If it's a wee bit different, then I can clarify on Tuesday.
Yeah. Yeah, right, let me have a wee look, 2 seconds.
Get the same answer.
All right, so that,
Last day, like,
yeah, I think maybe I've done more working previously, just in regards to like writing out the b over 2 and stuff like that. So I might have missed a few lines of working that I might have done previously.
Yeah, I think that's what it is. That's exactly what it is. It's
Yeah.
just, I think it's just because like it's not been like the plus C part and then adding like the -5 in at the end because it's been like the -5 from the very kind of top line. I think that's what's thrown me that it looked different even though it's not.
Okay.
But I've got it, I've got it.
Perfect. All right. So how does that tell me the turning point? Why is that relevant? All right. Well, the turning point from this, okay, we take the value that we find here, and we take the value we find here. That is going to give us our x term, that's going to give us our y term. But it's not as easy as saying -2. It's actually, that changes into the opposite sign, annoyingly. And then the y term stays as it is. So it'll be 2, -9 will be our turning point. All right. So the sign changes for our x term. Okay, so just be aware of that. The sign changes. All right, just to throw a spanner in the works and confuse you. All right. So let's look at that graph on the thing. Okay, on the thing. So previously we've worked out the turning points. Sorry, the factors, the roots.
Maybe that from using what was like MS graphs and MX plus.
Yeah, see?
Sometimes they can actually be turning point. No.
No, mx plus c is a straight line.
Right.
So a straight line wouldn't turn by any nature.
Oh,
So what I ask you the gradient. So the gradient's how steep that line is. That's where they would ask you that, or they would ask you where it cut the y-axis, but it wouldn't. It doesn't turn. So, all right. So that turning point, that minimum there, 2, -9, is what we've just worked out where that is. All right. So working out minimums and working out maximums is really important in this respect. It will give you the maximum value you can sort of achieve and where that would be. Okay. So that's the turning point one. If I was to draw just a generic parabola, it now makes a wee bit more sense. Okay, we find the roots by factorising. We find the turning point by completing the square. Now, the way they can ask you one of these questions, or the way they like to ask you one of these questions. Gosh. I'm not a very responsive board. Is they might give you the coordinate of the turning point. Say that turning point is 4, 1. And ask you, what are the values of A and B in the following equation? And we'll give you y equals x minus A plus B. So we can say turning point, we know it minus A, B. So A in this case is equal 4 and B is equal to 1. All right. The equation written out fully would be y equals x minus 4 plus 1.
Would it be that A is -4?
The letter A would be +4. We'll do a couple more questions and that will clarify that. Because I
Right, okay.
agree, I can see why you'd be thrown by that.
Yeah, yeah,
Sometimes don't like the way that these are worded. I think it
I know.
help you. Mm. You know what we're doing? We'll say let's do a few of these in the booklet. Going to put up the booklet instead of moving on too quickly. Where's my booklet? Where's my booklet? Okay, so we're in pack 2, if you've got it handy. And we're down at page 11. Down at page 38. So we look at page 38. Quadratics. Working with quadratics, blah, 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 sketching. Right, so that's the type of questions I've just shown. So actually, write down the equation of the graph shown below, which have the form y equals plus a squared plus b. Okay, just have a wee look at them, try and make sense of it.
This might be a silly question, but is this how difficult it gets in the exam, or are you going to add on things to this?
We'll add on things.
Oh gosh, okay.
So this is what I say, I don't like sometimes they word it differently. So in this case, this graph, am I right in this? How did I write in this? This graph would be y equals x minus 2. All right, so we've changed the sign of that. So it's similar to when we were moving it. Remember when we moved the sine and cost graphs on the x-axis? And if we were moving it to the right-hand side, it becomes a negative. Okay, so when you move the sine and cost graphs along the x-axis, if you're moving it to the right-hand side, that becomes negative. It's the same here. So in that bracket, when we're moving it to the right, that sign there is negative. If we're moving it to the left, okay, from 0, then it's positive. Okay, so if it's to the right of 0, that sign in there will be negative. Okay. So it works in the same way as when we were doing sine bracket x plus 45 or x minus 45. It determines which way it moves along the x-axis. So if it's a negative, that minimum is right of the 0 line. Okay. Is that coming up in your? That's not. See when I annotate that, does that come up on your board, your screen? No. That's good, isn't it?
What does annotate mean?
Writing on the board. When I've been writing on the board there, does that come up on your screen? No.
What, like writing the answers next to the questions?
Yeah.
No, it's not come up.
Ah, I love this board sometimes.
Woohoo!
2 seconds. I'll write them out again. So you can see all the fun things we're going to do with it.
So the last one is 0, sorry. Or
Yeah.
I should put 0 on there, it's just 0.
So the 0 is where the turning point is on the y-axis. So the y-axis is the vertical movement. So we don't put in, so it'd be plus 0. All right, let's try to annotate it properly. All right, so that graph there would be y x minus 2 squared plus 1. All right. If the turning point is to the right of 0, is okay, i.e. x is positive. Oh wait, I'm not gonna write that. I.e. it's a positive number on the x-axis, okay? So if it's to the right of 0 on the x-axis, then similar to when we were working out sine and cos, okay, this gives a negative inside the bracket. Okay, so if the turning point in the graph that you're showing, or the graph that you're trying to sketch, if it's to the right of the 0, all right, that sign is going to be negative there. All right, so that next one along, that turning point, and then the final one, all right. So let's get one that's got to the left of that. So these two graphs here. These two graphs here, even though it says -2 here, in our equation when we write it out, okay, so this changes sign. Yeah, still -4. All right, so the y-axis, that's on the vertical, that's on the y-axis. Y-axis doesn't change sign. All right, but similar to when we were doing sine and cos, the movement on the x-axis changes sign. All right. Yeah, another way they can ask you is to sketch the graph. Now to sketch the graph goes back to that when I started talking about this. All right, sketch the graph, we need to know a couple of things. Where it cuts the x-axis. Oops. We need to factorize it. Where the turning point is. The nature of it. We've not covered that. All right, but essentially, if it's a minimum or a maximum, so is it a min where it crosses y-axis. Okay. Sketch the graph. You need to know where it cuts the x-axis. So your factors, where its turning point is, completing square, where its nature is, max and min turning point, where it crosses the y-axis. Okay. I'm going to do one we've done already. Okay. So sketch the graph of x. Sketch the graph of the following trinomial. Okay. Okay, that's when we factorised it. So we've already done that, so that's where you go through CDT. Okay, you find the factors was x, is it +1, x -5. Okay, so the factors are x is equal to -1 and x is equal to 5. Okay, we did that at the start of the night. That full working. Find the turning point. Okay, completing the square and putting it into the form of y equals x plus a squared. Okay, to get the turning point. Okay, find that to be -2 -9. Okay, again, we've done this already. So we found that to be x -2 -9. So the turning point to use the nature. Okay, that just means is it a minimum or maximum? All right, minimum turning point will be a happy face, maximum unhappy face. Happy face is a positive x squared term. Unhappy, the negative x squared term. Okay. So in this instance, that x squared term is positive. Okay. If it was negative, we'd have a negative sign there. That being positive means it's going to be a minimum turning point. x squared minus 4x minus 5 as positive x squared term. Therefore, turning point is a minimum. It'll be in that shape, it'll be in the minimum shape. All right, just think positive, happy. When you're positive, you're happy. So the positive term, if the x squared term is positive, then you're going to be happy. All right, smiley face. Terms at the bottom. 4 is the only bit we've not covered yet. Now, when does this cross the y-axis? Okay, well, if we look at the shape it makes, okay, is that the graph we're doing? We look at the shape it makes. Yeah, you can see it's a smiley face, the minimum turning point. It crosses the y-axis when x is equal to 0. Okay, so the x-axis, when that is equal to 0, it crosses y. So your x coordinate is 0. Down the page. Any graph crosses the y-axis when the x coordinate is equal to 0. Okay. Now we substitute that into our equation. To work out y. So if our equation was y equals x squared minus 4x minus 5, we substitute in x equals 0 wherever we put an x. So y equals 0 squared minus 4 times 0 minus 5. 0 squared 0. 4 times 0 is 0. So y equals negative 5. So the coordinate would be x is 0 and y is negative 5. So that's us found out our 4 key bits of information about that graph. Okay, so if I was to sketch that graph out, I'd just put all that down on the paper. I know my factors are negative 1 and 5. All right, that's negative 1 and 5 on my x-axis. That's what factorization did. We found that using factorization. My turning point is 2, negative 9. So 2 on the x-axis about here, negative 9 is about here. So my turning point is 2, negative 9. And I'm cutting the y-axis at -5. So when x is equal to 0, zero, -5. All right. Then we'll just sketch. That's a perfect parabola. All right, that should be symmetrical. Got me a bit of slack. Of course, can.
Daniel, I'm sorry to ask, is it okay if I see the previous screen for just a couple more minutes? Thank you. Thanks.
One before that as well. So I'll leave that on the screen for 2 seconds and then I'll go back to the previous one as well. All right, so factorization to find where it crosses the x-axis. Completing the square allows us to find the turning point. Whether the x squared term is positive or negative will tell us if it's a minimum or maximum turning point. And substituting in x equals 0 into the equation will tell us where it cuts the y-axis. I'm going to change screen, is that okay?
Yeah, no problem. Thank you.
No. Right, anyone want me to cover anything else of that? Believe it or not, most questions spin off that type of thing. So they'll ask you maybe the coordinate of the turning point, or they'll definitely ask you a factorization question. We'll look at past paper questions together, don't worry. Right, final part of quadratics. All right, that's as hard as it gets. Final part of quadratics. Now, do not worry, because you get given this formula in the exam. So you do not need to remember this formula. I'm doing it in colour. I'm sort of wish another. It's hurting my arm. Did it in colour just to show you where the terms are coming from. But our roots are found by using the formula x equals minus b plus or minus root of b squared minus 4ac over 2a. You are given this formula in your formula sheet. You don't need to remember it. Right. It's not unheard of to get this in non-calculator, but you'll usually see if it's a factorization in the calculator paper, you'll have to use this equation. All right, as a rule of thumb. Solve the equation means find the roots. Give answers to 2 decimal points. This is your clue. That you're using formula. If it's saying give your answers to 2 decimal points and it's asking you a factorization question or solving the equation, you are using a formula. Because you ain't solving that in your head to 2 decimal points. X equals minus b plus or minus root of b squared minus 4ac all over 2a. Okay. B is 2, so negative b is negative 2. Plus or minus root of 2 squared minus 4 times 3 times negative 6. Okay, and we'll put that in a wee bracket if you want. All over 2 times 3. Now, you might be thinking, what the hell are you talking about? Why is there a plus and negative sign there? Remember, there's 2 roots. Remember, there's 2 roots. So you're doing this formula twice. You're doing once when that's a positive. You're doing once when it's a negative. So you're doing it twice. You're working out the answer twice. Remember, you're given this formula, you're given it with the plus minus there. Okay, so it's telling you what to do. That's the only part of the formula that changes. You can use your calculator normally, okay, for this. So -2, and let's solve the next bit. 2 squared is 4 minus 12 times -, in fact, just put in your calculator. See, you're getting big decimal. -1.12 and -1.79.
How are you? I've tried to put it into my calculator a couple of times and I can't get that kind of decimal. I'm getting whole numbers like 76 and stuff.
Yep, cool. Right, give me. You see my calculator on the screen?
Yeah.
Yeah, let's try that then. -2 plus root of, so 2 squared. Okay, so I've got that 4 times 3 times -6 in a bracket and everything underneath that root sign in a bracket. That's just sort of habit. You don't
Yep.
need to do that necessarily, but it just keeps in my head a wee bit tidier. Mathematics, right. So I'm going to press equals to that, and I get that sort of number. See if I press this SD button,
Yeah.
it gives me it in decimal, and then I can divide it by the bottom, 6.
It's coming up saying a syntax error.
So here's something, it's not calculating something correctly then. So making sure that underneath your root sign is correct. So you've got 2 squared minus all of this, -4 times 3 -6. All right, make sure that's in the bracket. So make sure, so you're going to get 4 times 3, which is 12 times -6. So you're going to get negative, what's that, 72. But that is then taken away. So negative a negative, so it becomes a positive under there.
I got it now.
Get it?
Got it. Yep.
Oh,
And then it comes up saying 10.71, and then are we just dividing that by 6?
I'm getting 6.71.
Oh my goodness.
You've got exactly what I've got on the screen.
Oh wait, hold on, I've not put a negative at the very front too. Hold on. Got it now. 6.71. Yep.
Perfect. All right, and then divide that by 6.
It's 7.71.
Oh fab, got it.
It was 6.71, 6.72. And so you can just keep that in your calculator. If you press divide, it takes that answer and divide it. So you don't need to delete it and then do it again. Ignore the fact that I did that. All right. So it's a wee bit confusing. You get tied up in knots a few times. Okay. However, that's as difficult as that sum gets. Genuinely. Okay, I'll do another one in the board. But using that equation, using that quadratic, and one of these always comes up, that's as difficult as it gets. Now, the one thing I would look out for is if the b term is negative. Okay, now, I'll say this right now, this term always has to be 0. Okay, and there'll be examples where it's not equal to 0. Okay, but we need to then rearrange and make it equal to 0. Okay, so 2x squared minus 5x. Okay, we'll say solve to 2 decimal places.
The b term as negative,
Yep.
does it become a positive?
Yep. Okay, so be careful with this term. It becomes positive, so it's going to be the opposite sign to that. So if it's a negative b term, that term becomes positive in the equation, in the formula. Just be aware of it. Okay, break that into 2. Make sure you can put this in the calculator and you're comfortable with it. Okay. You need to use brackets in your calculator to get that working. Make sure you can put it in your calculator and it works.
See the bracket is bracket is not easy to say you know. Oh, before you do the 5 square.
Yeah.
No.
So
I thought maybe things that would become positive endings.
In that case, you choose that. Yeah, so that, and there's all the negative,
Yeah.
and then if C is also negative, there's 4 times, whatever it is, times the negative. That's okay. So just make sure, alright? You are right, it will become a positive if we did that. So -4 times -4 would be +16 times 2 would be up there. But you've got enough negatives in there. If you don't, you'll get an error anyway, so.
How much time will get the same answer to since you've got because the semantic difference.
Are we getting on with our calculators when we're putting that in the calculators?
Yeah, it's a lot better now, actually. I managed to get both those answers fine.
Yeah. Brilliant.
I'm gonna have to try it some other part. I don't know why my calculator's not coming up showing me the answers that we need, but I'll work on it myself.
Right, well. Let's have a wee look. You can break that down if you want and just, and we're going to break it down anyway, for the simple fact that this part of the formula, okay, we're going to take that away. So we're going to look at that separately. That part of the formula, I'm going to write that again. It's called the discriminant. Now don't worry, we don't need to know anything else. Okay, so x equals minus b plus or minus root of b squared. Okay, we get given that formula. We need to be aware, however, that that part there is called the discriminant. And sometimes that's all we need. Okay, now what does the discriminant allow us to look, allow us to work out? If we just use work out the discriminant, okay, of okay, if we just work out the discriminant b squared minus 4ac, then it tells us if we've got roots or not. So if b squared minus 4ac, okay, the bit that's under the root sign, if that is greater than 0, okay, if it's a positive number, essentially, then the roots are real and distinct. So if it's positive, okay, so that's what that means. Let's break that down a little. If b squared minus 4ac is greater than 0, so if it's positive. And the roots are real. Okay, the word real means they exist. And the fact that they're distinct means there's two of them. It's not every parabola has to go through the x-axis. Some can sit above it, some can sit below it. Okay, they don't always have to go through the x-axis. So a parabola doesn't always have roots, essentially. So sometimes they'll ask you questions and say, does such and such have roots? Then all you need to do is work out the discriminant. B squared minus 4ac is a discriminant if it's greater than 0, if it's a positive number, then the roots are real and distinct. The roots exist, and there's two of them. If b squared minus 4ac is equal to 0, then the turning point sits on x-axis, meaning the root is real and equal. It exists. There's only one. I'll draw a couple of these out. All right, just to show you. But if b squared minus 4ac less than 0, if it's a negative, then the equation has no roots. Okay. So before we actually do that equation, before we actually use the full formula, we can actually work out if it's going to work or not. So you can work out b squared minus 4ac separately, and it's called working out the discriminant. And your equation only works if it's a positive answer or 0. Okay, you can't root a negative. So you won't get an answer if it's a negative. Let me show you what I mean. Okay, the question could ask, state the nature. That means if they're real and distinct or real and equal. State the nature of the roots. Of quadratic 2x squared x. It's not asking you to work out the roots, it's asking you to work out the nature of the roots. that is asking you whether the roots exist or not. That is asking you to use the discriminant to see if they're actually going to be roots. 2x squared minus x plus 5. We're going to use the discriminant minus 1 squared minus 4 times 2 times 5. So we have 1 minus 8, 40. Okay, so that's less than 0. So b squared minus 4ac less than 0. Therefore, no to this. Okay, so there's no real roots. Yep, that's what I'd actually say. Minus x plus 5. Okay, so you can see that parabola. You can see the minimum turning point. You can see the x-axis down there. The parabola doesn't go through the x-axis. So it's only when it goes through the x-axis it's got roots. The roots are where it crosses the x-axis. Okay. So that parabola doesn't cross the x-axis, so it doesn't have roots. Therefore, the roots there are no real roots. So it doesn't cross the x-axis. Okay. So I would write that in the exam. I would write that line in the exam. No real roots. For it's less than 0.
Daniel, could I have just a couple of split seconds of that last screen? I was almost done with it, sorry.
No, yeah, sure.
Thank you.
So if we go back to that question, 2x squared minus 5x minus 4. X squared minus 5x. Find the nature of it. Okay, so you'd use the discriminant. Find the nature of the roots of quadratic. And you'd use b squared minus 4ac. You'd have negative 5 squared minus 4 times a times negative 4. 25 minus 60 minus 32. Therefore, b squared minus 4ac is greater than 0. So it's positive 57. So the roots are real and distinct. So they exist, and there's two of them. Real and distinct. Real means it cuts the x-axis, distinct means it cuts it twice. You could then put that back into your formula. That's what goes in under the root sign. Oh. Go away. Why is that there? Did I get that out of there? Oh my God. There we go. If I was to put okay, that's that equation there. Then you can see now, hopefully on your screen, that it cuts the x-axis. And that's the two answers that we hopefully got, 0.64 and 0.314. Okay, so the nature of the roots are that they exist, it cuts the x-axis, and they're distinct. That's the formula sheet. That's the formula list that you get in the exam. It's the first one you get. The roots of ax squared plus bx plus c are given by this. Sine rule, cos rule. That's last year's question. State the value of a. Oh, you can see that or not. State the value of a in this form. That's from last year's paper as well, worth 2 marks. That's a discriminant. So it's not asking you to find the roots, it's just asking you to determine whether they're there. 2 marks for just saying b squared minus 4ac is greater than 0. So you just need to work that out. So 6 squared minus 4 times 4 times negative 1. And then you could say that. That's your answer. You need to say 2 real and distinct roots. Ignore that one. There's another one to asking you to put it in that form. In 2022, they asked you to sketch a graph out. There's a where you would use the quadratic formula. So you would put those numbers in the quadratic formula. By putting them in the quadratic formula, you get 4 marks. There's another one to quadratic formula. Write down the equation of the axis of symmetry. The axis of symmetry is where the turning point is. The axis that they're talking about there. Horrible question. The axis is essentially where it cuts the parabola in two. All right, so when we've been doing these parabolas, the axis of symmetry is the x value where it cuts the parabola in two. So it's your x coordinate of your turning point. All right. So your x coordinate of your turning point. So your axis of symmetry is where it cuts a parabola into, it's a symmetrical either side of that. So it's your axis of symmetry is just your x-axis, your x coordinate. So x equals, so my axis of symmetry of that one on the left-hand side there is x equals -2. The one on the right-hand side would be x equals -6. All right. So axis of symmetry is where we cut them in two. What else? So state the values A and B again. So -4 and 20. You can see that that looks a wee bit different to the form that we've been doing it in. Now, the reason they've written it like that is it makes it a maximum because the x squared term, if I was to break all that bracket up, the x squared term would become negative. So they've just written it in a different way, but they show you a picture of it. So that's why they've written it in that way. It makes the x squared term when we break that bracket up a negative. So if the x squared is negative, it's going to be an unhappy face. It's going to be that sad face. Okay. That's why it's written in that format. Just to throw you. Hence, so they're asking you to work out, or so they're asking you to reformat that, but then work out the equation instead of the turning point, the axis of symmetry. Okay, so instead of writing this, the turning point as completing the square minus 90. Okay. The roots of the equation can be expressed, find algebraically. The roots of the equation can be expressed dE. What is that asking? The roots of the equation can be expressed. I don't know what that's asking. Right, this is worth 4 marks. What I assume this is asking it's just this second bit that's thrown me a wee bit. That first part of the question, question A, was completing square. So that's all they've done there. That's just completed in square. All right, so that first part is just completing the square. Okay, with that quadratic. That second part, my guess is you need to put it into the quadratic formula. So let's just have a wee look at it. Now, why I think that is because you've got that plus and negative there, and you've got a root sign. So let's just throw that into the quadratic formula and see what we get. So x is equal to negative b plus or minus root of the now this was in the non-calculator. So negative b is 6 plus or minus the root of 6 squared minus 4 times 1 times a big number, negative 81 equal to a, which is 2. That's quite a lot to this question. Let's simplify the root as well. There you go. Plus or minus, so that's root 36 minus no trouble. 4 times 81. 4 times 81 is 160. 324.
Can I just
That's a
quickly ask,
cool
did you just say that this was in the non-calculator question?
Yeah, this was in paper 1. That's why I'm trying to figure out for you.
Who made that up? Torquemada? God's sake.
So, what's that? 36 plus 324, so that'd be 36. 360, 360. That's simplifying that, so it'll be 10 times 360. Nice, this, isn't it? Literally run out of space. This is a hell of a question. Don't get thrown by this, by the way. This is as hard as I've ever seen. So your answer would be 3 plus or minus 3 root 10. Jesus Christ. Is that right? 3 and 10. My God, that is. Okay, that's what you do. That was in a non-calculator paper. Don't let that throw you or put you off. All right. Why I probably have done it in the past, but it doesn't ring a bell. But the reason I knew that was that plus or minus. All right, that plus or minus tells me that I'm using the formula because it's got the plus or minus and the root. Now, once I put the numbers in there was a few difficult bits. The 4 times 81 was quite challenging, but take that to one side and just do 81 times 4 in a column method. So that would be 4. 4 times 8 is 1632. 324. Okay, so take it to one side and do that. Another bit that might throw you is when you get root of 360. Now, that's a big number, I get that. But hopefully, because you're trying to find a squared number, that 36 jumps out at you. Okay, that 36 jumps out at you because I can root that and get 6. So that looks a lot worse than it probably is. It might throw you a wee bit because you never see something in this form, but there's always clues. There's always clues, and there's always a way. Okay. What's the time? What's the time? We're gonna work clock.